that's not an island. It's just that North Korea looks like the ocean, right? Because of lack of development. Right? You can look at this. This is one of those classic things where we say, look, like the fundamental determinant of development, really, the environment doesn't really matter that much anymore at all. It's really about institutional variation. Right? We look at something like this. We say, look, this is the two Koreas have wildly different outcomes in terms of a lot of things that we care about, but it's not environmental, strictly not environmental. Right? And so there's sort of these two questions that I think you can ask when you start thinking about bringing the environment into development economics, or just development in general. Right? The first is, how much has the environment influenced development thus far? Right? Sort of the kind of historical pathways question. Right? And I think the most obvious important note that we hit on this is how much disparities in current levels of development have something to do with initial conditions or the environment or geography, however you want to think about it. Right? And the second question is, how much is development still influenced by the environment? How much is it going to be influenced by the environment in the future, if at all? Yes, sir?
So when you use the word environment, what are you including in that?
I'd say the natural environment, basically anything that humans don't do. Fair? Yes?
In regards to the issue of the environment and development, in terms of development disparities, are you talking of disparities among countries or within countries?
Either way.
Either way.
Either way. Just in general. Like, there's plenty of things where you can say, oh, generally speaking, why do we call it the North and the South? The North and the South, right? It's like it's tropical versus extratropical. Is that meaningful or is it not? Is it still meaningful? Or you can have the, was it meaningful in the past? Perhaps, right? And is it still meaningful now? Will it be meaningful in the future? Well, right? So in particular, when we think about looking forward, we can say, and this is kind of relating back to the idea of quote-unquote sustainability, right? How much does our ability to maintain and improve development outcomes depend on the environment?
So how do you measure these things?
I'll show you. And sort of, there's plenty of evidence that we're doing lots of things in the natural world, right? Should we be worried about it? Right? So, these are not new questions, right? These are questions that people have asked for a long time in a bunch of ways, right? Most recently, the sort of classic Sachs versus Acemoglu institutions versus geography debate, right? And so there's a caveat. I'm going to show you a couple of things that are not well identified, and then I'll start to get more and more identified, right? But the caveat, right, correlation need not imply causation, right? Which is cool. Let's just keep that in mind as we show you some things. That doesn't mean that correlated things need not be causal, right? A lot of causal things are correlated, right? And it's, and in particular, sort of what I'm going to present to you guys and sort of hopefully wrap up with is that the introduction of identification into modern development and environmental economics has sort of created this new field where you get this fantastic identification from natural processes that we don't necessarily affect ourselves, right? That sort of come out of the natural environment. That's let us get very rapidly in the past couple of years a much better idea of the extent to which development is influenced by the environment. All right, so now back to some pictures. This is a photo. Actually, not a photo, obviously. It's an etching. The famine in India, natives waiting for relief in Bangalore. This is from the 1870s. Right, so we can look at something like this, and then we can look around ourselves. We can say, well, obviously development has changed things a lot. We used to be incredibly dependent on the environment. Right? Famines are, as Amartya Sen famously said, not strictly products of the environment. Right? They're very political things. Famines are about not being able to distribute the food that you have, and not being able to, the government not being willing to borrow and buy grain from elsewhere. But that doesn't mean that the stressor that causes famines isn't necessarily originally environmental, right? A lot of the major famines that we know occurred in the late 1800s occurred perfectly timed with large El Nino events, right? Falls in rainfall, X, Y, and Z. Right? So if you look at this, you can say, okay, well, it's maybe we've just kind of gotten past the point where this matters anymore. We don't have famines in Bangalore anymore, right? We have, as in terms of university and IT and all kinds of other wonderful things. All right, and why is that? Well, you can think about things in terms of, say, human technological progress, right? You can think about the Green Revolution. This is wheat yields in developing countries since the 50s. I can say, we've done a really, really good job in a very short amount of time of taking ourselves from being incredibly dependent on the environment to, in a lot of ways, at least, sort of how I think most of us think about things, and I'd say, in a lot of ways, very seriously, truthfully, no longer dependent on the environment. Right? This is, ever since the Green Revolution, we no longer get the major famines that we used to get. Or you can also think about things like the eradication of smallpox and public health in general. We used to be, racked by plagues year after year, especially in urban centers. And this was relatively recent as fast as well, right? As late as the early 70s, we were having massive smallpox outbreaks. And smallpox is horrible, like as you can see, right? Really incredibly disfiguring, kills people, X, Y, and Z. And this is 73 in Bangladesh. The very last case of smallpox known to humans was 4 years later. The guy is named Ali Malim. Last case of variola minor, which is the less extreme case. There are two types of smallpox, major and minor. Right? We eradicated them both, or we have them in labs. We got rid of them. Right? So we've been triumphing over the environment in a bunch of really non-trivial ways. We can think about things in terms of how we react to natural disasters, right? So on the left is a photo of the ground in the southern Philippines in Davao Oriental. This is after Typhoon Bopha, which was I think last month or the month before. Really major typhoon that hit a part of the Philippines that doesn't normally get hit by typhoons. Devastating, right? And here we can see the utter devastation that was wreaked upon Japan by Typhoon Roke in 2011, when a whole bunch of salarymen were made significantly late for work, right? And we can think, Japan and the Philippines are very, very similar typhoon climates. They're hit by a lot of the same typhoons, and outcomes are radically, radically different. You can look at this and you can, okay, maybe there's some degree to which, at lower levels of development, the environment affects us, but maybe we can just adapt out of it, right? Maybe if we could just make the Philippines look like Japan, we wouldn't have these kinds of problems, and we could stop caring about things like typhoons. Or we can think about, again, public health-ish type outcomes that are linked to the environment, things like malaria, right? So this is a map showing the spread of malaria from functionally, the original distribution, here timed at 1900, but as far as we're concerned, the original distribution of malaria endemicity, right? And what happens over time? What do we see? Well, in 1900 and then 1946, after World War II and a whole bunch of eradication efforts, we've shrunk malaria from its presence in places like New York City back in the 1800s when we said bad malaria in my hometown. Or say in France, England, in London, malaria. Shrunk down some more. We see it, after World War II, we still get malaria in parts of the southern United States. Say Italy, where we get the original word for bad air, malaria, because they thought it came from the swamps. Yes?
I'm not understanding this graph.
Sure. This is, yes.
Is this at what period of time where malaria was endemic?
Exactly. Right? So this is where we had malaria at different periods of time. The light is the earliest extent, and you can see over time, we get shrinking and shrinking to the present extent of malaria. Right? And we can look at this, we can tell ourselves a story that, yeah, this is the world developing. Right? Where is malaria getting kicked out? Americas, Australia, Japan, Europe, Russia, the developing nations, kicking out malaria. Malaria is a problem of development. Right? But if we think about it just like this and we don't bring some science back into it, we ignore something really important, which is that the extent to which it is easy to eliminate malaria scales strictly with your climate. Right? So this is a map of potential malaria endemicity. Right? And so what we're showing here, this is a stability index. 1 is sort of perfectly stable at present conditions with the current types of malaria that you have. This is sort of averaged over the years. You used to get seasonal malaria in parts of the United States and stuff like that. And what we're seeing, well, sub-Saharan Africa, where malaria is particularly bad, basically has a climate that's so good for malaria that getting rid of malaria there is functionally impossible. Right? If you could do full and utter eradication of malaria from the human population there would still be reservoirs and livestock and X, Y, and wild animals. You basically cannot get rid of malaria in Africa, as far as we currently understand it, from a public health and epidemiology point of view. Which we should care about, because malaria has potentially huge costs. Lots of sickness. I had malaria once, and it's horrible. Worst pain I've been in basically ever, at least from sickness, right? As I can see, maybe the environment does have a fingerprint after all. Right? We can think about this in terms of more generally in terms of geography. This is a map that I particularly like. This is the, here we go. Temperate climate zones, so sort of the standard Western European / Eastern US type climate, that are within 100 kilometers of the coast or sea navigable rivers, showing GDP per square kilometer. This is 1995, hasn't been updated. This is an older map. But I like it because you look at this, you say, okay, intersection between the obvious sort of trade-ish reason, distance to ports and your ability to get your products overseas, which you would imagine correlates with development outcomes, and climate outcomes. The two of those together, let me screen that out, and 60% of gross world product in 1995 was in one of these zones. This sort of interaction between something climatic and something geographic. We can think about something like, say, agricultural outcomes. Right? This is showing the fraction of crop that's irrigated. And if we think sort of all the things that we've seen over the past couple of days, thinking about sort of the role that agriculture and the agricultural sector has in larger development, and say, you know, the need for greater agricultural productivity, just so you can sort of feed your population and go on to other things, or when we think about transitioning economies, right, we look at this, we say, well, again, we have this massive lack of irrigation in sub-Saharan Africa. Why is that? So it's a variety of reasons. One of the major reasons is that the regular flow of rivers that you can get in a lot of other places, like say the Western United States, the Andes, all over Asia, well, you need a bunch of glacial mountains, right? You need precipitation that can fall there. You need to be able to sort of get that water. If you don't have that, you need a ready supply of groundwater and a lot of energy to pull it back out, like you get, say, in the middle of the United States, right? And what's the problem with not having irrigation? Well, that puts you at extreme mercy to the climate. Moreover, right, you can think about something that's a little bit more historical, right? You can think about, say, the distribution of the primary fuel that we used during the Industrial Revolution. We can look at this and say, okay, well, you know, as soon as we invent the steam engine, we have to power it with something. And whatever we're going to power it with, we need to be able to have around. And I think it's, you know, this is, again, correlation and causation are not the same. But we look at this and you say, okay, well, it's the early 1800s, and you'd like to take advantage of this fantastic industrial revolution that's going on. You'd like to be able to get some coal. And you'd like to not necessarily have to have it shipped to you with all the tariffs and whatnot that are intervening. Right? So you look at this and you say, well, you know, England had lots of coal, America had lots of coal, most of Western Europe, Australia. But outside of sort of southeastern Africa and, you know, northwestern South America, you didn't really have this. Oil distribution is a little bit different, but of course we learned to use oil decades and decades and decades after we learned to use coal. Industrially, that is. We were using coal for a long time. So, you know, you look at this and you say to yourself, all right, so that's a bunch of cool maps and whatnot, but what's meaningful in this, right? What can we actually take out of this thinking about development, right? And so the sort of the other thing that I'd like to impress upon us is that we're living at a very odd time in Earth's history, right? I originally had this as world history, and I was like, no, let me pull out the world and put in Earth to sort of impress upon everyone that we're not just talking about human history, we're talking about the larger scope of how the world works in the natural environment. Right? And so we can begin with humans. Right? So this is a graph of world population over time, going back 2.6 million years. It's obviously not perfectly to scale over here. So we have the Old Stone Age, the New Stone Age. If we're thinking about prehistoric hipsters, Old Stone Age is much more important. Right? But we see the world population was fairly stable for basically all of history. Right? There's some belief that there's a couple of bottlenecks where we got reduced down to a couple thousand breeding pairs of humans, or pre-humans at random times, you know, fluctuations, Roman Empire was bigger, X, Y, and Z, but more or less not that different. We're significantly below 1 billion people around the world. Right? Around about 1800, when we hit the Industrial Revolution, human populations have grown quite a bit, and since then, what's happened? Absolutely astronomical growth in humans. Right, so if we think about this from a sort of more ecological point of view, we say to ourselves, well, humans demand resources, because we do. Right, we traditionally got them from the natural world, because we did. And if we think all the way back to, say, the Lascaux cave paintings, we can think about the fact that that was basically humans trying to scramble to extract the natural resources that they needed to survive. Right, it's very fundamental to who we are and how we exist, is our ability to take things out of the natural environment and put them in our mouths or on our backs or under our feet. Right? So this is one way to look at it. We can think about how much the world has changed in terms of the total number of humans. We can also think about how much the world has changed in terms of, say, the activity that those humans are engaged in. Right? So this is taking data from Angus Madison, who's the famous historical economist, and Brad DeLong, who's the famous macroeconomist, who I have no idea why he's doing this, but he's a cool guy. Right? So this is world per capita GDP from 10,000 years ago, which was around about the end of the last ice age. I don't know how he was calculating this. I know how Angus calculates his stuff. I don't know how Brad DeLong got GDP per capita going back to before any type of record whatsoever that we have. But I'm sure he was making some nice educated guesses. And so what do we see? Well, aside from the fact that this is a hilarious graph, and not, yeah, just like, I wanted this part, but I couldn't find a good one. So I'm showing you guys this one. It's funny. Right? But so what do we see? Well, coinciding with the burst in human population is a burst in per capita income, right? A burst in production and economic activity. So not only do we have more people by orders and orders of magnitude compared to what we had before, but what those people are doing and the impact that they have on the natural resource base is astronomically higher per person than it used to be. So what does this mean? Well, I think one of the nicest ways of thinking about it, right, is sort of, maybe this is being a little bit too much of an ex-physicist, a reformed physicist perhaps, is to think about it in terms of, our sort of our thermodynamic load on the planet. How much energy do we need? What are we taking out of things in the most fundamental unit that we can care about that approximates something like, dollars in an economy and production? Right? We think about it in terms of energy. Right? What does this show? One of the nicest and tightest scatter plots you can get, I'd say, energy consumption per capita and GDP per capita. Right, so we see there's some variation. There are some countries, cough, 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 Russia, that are not particularly efficient per person. Some countries that are a lot better. But in general, if we think about development, what does that mean? That means pushing ourselves further up along this, increasing per capita income, even if GDP is a horrible proxy. It proxies for something that correlates with things we care about. Right? And so it's further increasing the total amount of energy that we need. Right? Engaging in development is pushing all of these dots further to the upper right. So why do we care about that? Well, again, to show a graph with a ridiculous axis, but this time not ridiculous data. This is showing the concentration of carbon dioxide and methane as inferred from Antarctic ice sheets, and specifically bubbles trapped in that ice. Right? And what's also nice about sort of paleoclimate data and all the awesome stuff that climatologists do is you can also infer temperature by looking at various ratios of isotopes that are of various weights that evaporate at various rates off of the ocean. Sort of lets you back into what the global temperature probably was in those days. And what do we see? An extraordinarily tight coupling between the two primary greenhouse gases other than water vapor and temperature. Right? And so why do we care? Well, since industrialization, right, we're showing this is not 1800, but rather 1900, we've seen an extraordinary increase in carbon dioxide, nearly a doubling, pushing it, and an extraordinary increase in methane as well, and the beginning of what promises to potentially be an extraordinary increase in world temperature. Something that we might potentially care about, especially when we start thinking about things like, say, agriculture, a variety of other things that I'll show you in a couple of slides. So this is a major change in the Earth's history that we've invented, and it's incredibly fast. Insanely, insanely fast, right? This is in thousands of years, right? That's 1,000 year. I think, so you can think about what the impacts of that could be, and there's a whole, the climate literature is insane and rapacious and growing at an insane, there's multiple uses of the same word, speed. But when you think about what this means for the climate and for us in general, I think one of the nicest ways of conceptualizing it is looking at things that shouldn't be changing fast, that are changing very quickly. Right? One of the best examples of this that I know of, and I think one of the most intuitive ones, is looking at the ice sheets. Right? So we get this graph from Vostok in Antarctica. Right? 400,000-year-old ice sheets, 400,000-plus-year-old ice sheets. Right? Same ice has been there for 500,000 years. This is recent melting in Greenland. One of those 400,000-year-old ice sheets, or actually not quite that old. Greenland ice sheets are on the order of 100,000 years old. Old, melting at a ridiculously fast pace. I don't know if you guys saw, but there was a flash melting event in Greenland this past summer that freaked everyone in the climate community out. Right? Recent estimates are that Greenland is losing ice mass at a rate that exceeds. This is a paper from 2009. This is showing the terrifying decrease in ice mass. Right? Current rates of ice loss, as updated from this past summer, radically exceed this. Yeah, that's a pretty good measure that something is changing very quickly at a rate that we wouldn't normally expect it to be changing. Yes?
Just as somebody who's completely illiterate in this area, but what would the change be before 2002?
What did it look like before 2002?
As in the incline is like this, right? So was it like relatively flat?
Yeah, so if you go back far enough, like you say, when we first started getting loss of the ice sheets that was measurable, you can kind of think about it as flat and variable, and this is when we start showing it because this is when we start to see change. Right, and there's seasonality in there because, summer melting, winter deposition. But basically flat. Right, we can think about other things we've done to the environment, right? So this is a picture. You can see Australia here, South America, South Africa, Antarctica. The ozone hole right in the middle, right? Discovered, or at least announced to the public in 1985. Right? So why do people get scared about the ozone hole? What's the problem with the loss of ozone? What's the sort of underlying issue? Well, we had these really nice cheap propellants called CFCs, which we enjoyed because they were completely inert, didn't really interact with anything, so you could use them as a compressant for things like hairspray and refrigerators and all kinds of stuff like that. The problem with CFCs is they're lighter than air, so you spray your hair to do your beehive in the 1960s, and some of that goes up into the atmosphere and kind of trolls around, and eventually ends up, because the atmosphere mixes constantly, over Antarctica, where through a relatively complex process that people started to understand in the late 70s, it then binds with ozone, catalyzes the ozone, and then it goes back to being a CFC. So it just kind of sits up there just munching away at ozone. What's the problem with destroying stratospheric ozone? Stratospheric ozone blocks ultraviolet rays from the sun. Right, so I don't know if how much you guys have spent time in, say, the southern hemisphere, but I got to go to Santiago in Chile a little while ago, and you're there, and there's like the weather report, and you're like, oh, it's going to be sunny today, 60% chance of humidity, and UV danger is extraordinarily high. Again, so please wear sunscreen and don't go outside. Right, so like now part of the standard weather reports in Santiago, and that's with this grade of ozone depletion, not the kind of ozone depletion we see here. Right? So what do? Well, we stopped emitting the CFCs, right? We signed the Montreal Protocol in 1987, sort of this major environmental issue, everyone freaked out about it, we're like, okay, cool, we solved the problem, right? No, we just didn't let it get worse. Right? If this was sort of one of those chance discoveries by scientists that averted something horrible. Because if we had just continued emitting CFCs at the exponential rate at which we were creating them, then we would have just had this hole expand across the entirety of the Earth, causing extraordinary damage to humans in the form of things like skin cancer, right? Also extraordinary damage to, biota around the world, genetic damage to animals, X, Y, and Z. Really potentially catastrophic. So we get right. It's funny when you think about this. This is one of those things that could have really, really, really radically changed the Earth. It was like, whoops, good thing we didn't do that. Another way of thinking about how much things have changed and how quickly, right, is to think about things like, say, fisheries. So this map is showing the percentage from 0 to 30 of the total productivity of the ecosystem. You can think about this in terms of calories, if you like. Total amount of solar energy that's going in that we then capture in terms of fish. This is the percent of that productivity that we take out every year in our fisheries. Up to 30%. Doesn't sound like something that can be maintained, right? If you're pulling out 30% of the calories in the ecosystem to maintain current levels of fishing. Right? So we see there have been a variety of fisheries collapses lately. And actually fisheries is one of those areas where it seems like institutional reactions have sort of caught up relatively quickly. Right? We've done a lot in the past, really in the past couple of years since I first started doing this kind of work even. We've done a lot to sort of reverse the decline of the fisheries, which is great, but not everywhere. And not strictly. There's still extraordinary damage that's already been done by that sort of fishing. You can think about things in terms of, the long, long time scale. You can think about things like extinctions, right? Current estimates of the rate of extinctions. This is sort of so you can infer from the fossil record when animals went extinct. You can estimate that for, this is marine species and mammals, on the order of one species went extinct for every 1,000 species that existed every 1,000 years. And things moved slow in the old days. What happens now? Well, current rates of extinction are about 1,000 times higher. Right? The future rates of extinction that we can sort of back into from climate change and exposure in other ways are significantly higher than that. That's a very, very, very rapid change, right? Remember, the difference between the distant past and the recent past, as far as we're concerned, is, maybe 1800 is too soon of a line to draw, but let's say the Roman Empire, right? As far as the Earth is concerned, that's nothing. If we want to think about some kind of staticness in response between the environment and us, we can't just look over our own history. We have to look to the history that's come before us. Right? So you can think, there's so many things we can show in terms of how rapidly the Earth's environment has been changing because of our own behavior. This is a nice one as well. This is pre-agricultural forested area. This is actually potential. You can't get perfect data on this. A lot of these things are hard to infer and require a lot of effort. But this is sort of, you can think of this as what the world's forests look like maybe at the end of the Holocene, right? Right when the humans first start, writing things out and sharpening up some nicer tools than they were using before and potentially going out and cutting down some trees. right? And this is it today. So what happened there? I think I lined these up. Yep, there you can kind of see it. So you can see, well, Western Europe and Europe in general, gone. Much of the Soviet. Much of the Russian forests, gone. Look at India. Extraordinary, right? Look at China, Southeast Asia. Thinning all over the tropical forests. Again, when has this happened as far as we're concerned? Well, the deforestation is a longer running game, right? There's a lot of deforestation in Europe and, early medieval times and Roman times, et cetera, et cetera. One particularly interesting story actually about Japan. Japan became almost totally deforested back in the middle of this past millennia, and then under one of the shogunates became significantly afforested again. Kind of interesting. But as far as the Earth is concerned, that's a blink of an eye. So once you want to start sort of thinking about things, so it's probably a good way of putting this is that we're at this very funny inflection point in history on many, many, many things that we care about. And I don't mean history in the human sense, although that's obviously true. History in the environmental sense, right? And so what does this mean? Well, so and on the one hand, you can say like initial conditions and geography like trivially influence development and economics, right? New York City is not in the middle of the Tibetan Plateau, right? You don't have massive human settlements in Antarctica, X, Y, and Z. Trivial, right? Maybe that could just be an initial condition sort of issue, right? The extent to which the environment has influenced us thus far, right, is really an empirical question. You could potentially imagine an alternate state of the world where instead of Great Britain colonizing India, India colonized Great Britain, or the Zulu Empire came to fruition significantly earlier than it did and took over all of southern Africa and created its own state, X, Y, and there's all kinds of alternate histories you can come up with. We don't know how realistic that is, right? If you want to think about it in a more sort of sciencey econometric sort of framework, we don't know what the prior probability that would have had, right? And why is this important to understand, right? So one, you want to understand how development has come to be, just because for not purely out of academic interest, but sort of to understand, relative to other things we care about in development, how much does the environment matter? I'd say that's secondary though, because if we think about all the things that I just showed you in terms of how quickly the world environment has changed, then we really care about future development specifically as a function of the environment. Because if we get away from the social scientists for a bit and we go talk with the scientists tell us that we should be terrified, right? That the things that we think of as constant are not constant, at least not as far as the world is concerned. If we think about, say, development as being something that's happened over the past couple of decades or centuries, that's fine, but we can't take as sort of given everything that we get right now and everything that we've been able to use. Right, so this brings us sort of to the field overview, right? So I'm calling this the new environmental development economics. We don't actually have a name for this. I don't even know if it is its own field, but we'll just say there's this new
You're
subfield of
pioneering
economics.
the field, clearly.
What's that?
You're pioneering the field.
Pioneering the field, there you go. The new environmental development economics, right? So, it's for most of human history, humans have cared about the extent to which the environment influences them. Right? There's been all these theories made and supportive evidence. You can find Adam Smith and Ricardo writing about this sort of thing. You can find this sort of thing in, say, the old Roman histories and the Herodotus. Right? And a lot of times what we got out of this was just people theorizing, and oftentimes not to but just sort of like what Joe was just saying at the end of his lecture this morning. There's a certain degree of cognitive dissonance avoidance. Right? People like to do a lot of this theorizing so that they can explain why it is that we in Rome are so much better than those barbarians to the north, or why we in England are so much better than those savages in the global south, right? And for, I'd say in a lot of sort of modern development, at least up until relatively recently, we looked at these sorts of arguments, and the shadow of things like phrenology and eugenics was so strong that we just shied away from talking about the environment's role in human development at all. With good reason, because we had horrible outcomes from that, right? But that doesn't mean that the questions aren't important. And so what's happened recently, I've argued, basically we had two things, and I'm going to talk about economics. And again, I fell into economics by accident, if you will, because I was just looking for this kind of work-ish. And economics has a lot of the quantitative frameworks that are particularly used for this, and sort of the rigor of modeling. I'm just going to, if you want, just substitute quantitative social science in here. Right, but I'd say, so it's sort of two things came out of this, right? We have the emergence of resource economics, environmental economics. It's separate times in the 1900s, right? Resource economics with hoteling, I'll say we'll date it. Environmental economics in the 70s, following the environmental movement, sort of early work by people who are still alive and writing today. Right? Then that sort of first allowed us to start coupling human systems with natural systems in an explicit way, something more than just sort of like writing paragraphs about how heat makes people lazy or something like that. So on the one hand, we have the growth of this. Now what else do we have? Well, we have the identification revolution, right? We have the ability to sort of start actually trying to think about human outcomes in a way that's causally sound. We can start making causal inferences. Right? What came from? This came from medicine and medical stats, right? And sort of the idea of randomized control trials originally, but just sort of the rigor that's required to sort of think about how one can make a causal claim. Right? I think it's not in any way insignificant that a lot of the interest in identification came from development economists, development microeconomists. Right? What I'd say is that you sort of take these things and you put them together, you add a liberal dash of science, and you get what's basically a newly forming field in economics, right? Which is environmental and development economics. Right? We take all of the good parts of the identification revolution and development, and you don't necessarily have to have perfectly identified work at all. You don't need to have identified work. You just need to be able to say what you can and can't say, and what you can and have to defend in terms of more, further evidence. Well, I often think, when people claim that the only way that you can do work is if it's well identified, I say, well, how do we solve legal cases? Right? We have to make a bunch of decisions in society about things that aren't necessarily well identified. You can't rerun a given night in Detroit to see whether or not that crime would have occurred in fact. Right? You piece together evidence, you make a case, and you have to make judgments, and that's life, and it's tough. Right? Is that any more or less sound than the fact that any given statistical outcome that you get is not necessarily indicative of anything other than likelihood of being true? Well, it's similar degrees of uncertainty. All right, so now what I'm going to do is I'm going to show you guys a couple of papers. Until when do I have that card?
Well, we're supposed to end at 3:30. What we can do is you can either penalize the people by eating into some of their coffee time, 3:30 to 4, and that's entirely up to you. Just as people start today at 20 to 3.
20 to 3. All right, I will aim to end you.
20 to 4.
20 to 4. Done. You will travel back in time. So I'm just going to give you a quick overview of some particularly interesting things that have come out of this literature. I'll try and make these fast, and then I'll give you guys a little bit more of a view of the paper I was going to present to you. Right, so when we start looking at this, right, the new environment and development economics, there's some papers that just come out of straight up development, but they have an environmental focus, right? I imagine that a bunch of you guys, especially if you're more of the applied microdevelopment type, know this paper by Kramer and Miguel, right, from 2004. What we're showing here is basically months since a deworming treatment was introduced to one group that had the treatment and one group that didn't, versus a separate control group that's not shown. Right, and over here we're showing is school participation. Right, what is this showing? This is showing that when you introduce deworming pills, right, these guys start going to school. These guys got the deworming pools 12 months in. They start going to school more, right? Worms have a really great caloric burden on people. They make them more tired. Right? Badija does work on the fact that when you get to eat better, you get to do better in school. Right? So we can say, oh, well, this is originally very much of a development economics intervention sort of paper, but really it's also an environment paper. We're talking about the burden that soil helminths and hookworm and that sort of thing have on human development. You don't go to school, right? In extreme cases, you start getting stunted, your brain doesn't develop as much because you're starved for calories. This is environmental impact. Worms have a negative impact on us, right? This is a famous paper, not that famous, but a reasonably famous paper recently, Machini and Yang, right? Under the Weather, Health, Schooling, and Economic Consequences of Early Life Rainfall. What these guys do is they go in and they take adult outcomes for women, and actually not just women, but women in Indonesia, things like how tall they are, self-reported health status, how rich they are, how many grades of schooling they've completed, and they tie that back to rainfall conditions around the time of birth. Why does that matter? Well, if you live in an agricultural community and you have a bad rainfall year, you have poorer crops, your family is poorer, you're resource constrained, you live in a world where there's some degree of gender bias in favor of sons, what's going to happen? Daughters are going to be particularly hard hit by a shock to income. So what do we see? Worse rainfall conditions result in women decades later who are shorter, less healthy, less educated, and poorer. It's pretty linked to development. This is actually not in a larger conversation, but yesterday Sanjay and I were talking. We were talking about sort of this theory that comes from out of anthropology, that a lot of the difference in gender preference, right, the gender preference that would drive something like that rainfall result in yin and yang, can be tied back to what kind of agriculture you can practice, right? If you have low marginal productivity of labor, then everyone needs to be used, men and women alike. If you have a hoe-based culture, well, then the women have something to do. There's more equality in society. If you have a plow-based culture, then you can just let the men drive stuff to do the production, and women are less economically valuable, less powerful in the household, right? The job market paper from Harvard Econ 2 years ago. I'll read the abstract. The female population deficit in India has been explained in a number of ways, but the great heterogeneity in the deficit across districts within India still remains an open question. This paper argues that across India, a largely agrarian economy, soil texture varies exogenously and determines the workability of the soil and the technology used in land preparation. Deep tillage, possible only in lighter, looser, loamy soils, reduces the use of labor and cultivation tasks performed by women, and has a negative impact on the relative value of girls to a household. The anthropologists are. But this is econometrics. The analysis finds that soil texture explains a large part of the variation in women's relative participation in agriculture and in infant sex ratios across districts in India. That's the environment directly impacting the environment. Exclusion restriction here holds? Maybe. You can think that people might sort the different types of soil areas based on gender preference, but that seems a little odd. Talk about soil. This is, and I won't belabor this too much, especially because I'm trying to rush through this. This is from Rick Hornbeck, AER 2012, Nature versus Nurture. What does he do? He goes back and he looks at land values in the United States, breaks them down by fundamental agricultural characteristics. Soil type, temperature, precipitation. Finds two things. One, if you had crappy soil back then, crappy soil now, the value is low, right? The rank order is preserved. The good land is still the good land, the bad land is still the bad land. Technology can kind of shift you around, but not that much. And in particular, he says, okay, well, we had a bunch of different things that sort of happened, especially in terms of our ability to take advantage of different types of soil with artificial fertilizer, X, Y, and Z, up until maybe the 40s. But now we see this is standard deviation by each of these different characteristics. And it's been basically flat since then, right? We haven't sort of managed to narrow things down and decrease the gap between good land productivity and bad land productivity with all the technological advancements that we've been able to make. Right? Nature is still a fundamental constraint on our ability to produce. Right, so what's interesting in this literature is that we're starting to see more and more just people who are trained in good applied microstyle identified econometrics going out and doing work in areas that are traditionally considered part of the sciences, like agriculture. Yes?
When you say good and bad lands, do you mean for agricultural principles?
Yes, that was all agriculture.
Oh, okay, so when I have sand and oil, that's not...
Yes, exactly. That was strictly, yes, that was a strictly agricultural, yes.
Right, because it can...
Yeah, because of the productivity. Right? So this is some work by Wolfram Schlenker, who was at Columbia, currently on leave at Berkeley, and Michael Roberts, who's, I believe, University of Hawaii. Did you know that, by the way, Amir? You just moved. What is this showing? You can ignore the abstract, but basically what they do is they go in and they say, look, there's all this sort of concern about whether or not climate change is going to impact agriculture. So what they do is they take individual counties in the United States, they take their temperature history, they take their yield history, and using a variety of fixed effects and X, Y, and Z, they start reconstructing yields as a function of temperature for each of these different crops. Corn, soybeans, cotton. Now we know from the agronomy literature that yields tend to be nonlinear above a certain point. Plants get too hot, they no longer respire as well. Generally speaking, the warmer it is for a lot of these plants, the better they do, up to a certain point. Right? So around 29 degrees Celsius for corn, 30, I think, for soybeans, around about the same for cotton, a little bit higher. You get this massive fall off in yields. Massive.
What happens when the temperature rises?
So basically what you do is you look at each county, and you can look at yield outcomes by looking at the total exposure to heat. Right, so this is temperature on the bottom.
Is it across the United States?
across the United States.
This is at a point in time.
No, this is using time series data.
Okay.
And actually, and the heat measure in this specific case is using degree days, so sort of the cumulative amount of heat
Right,
you've been exposed
right,
to
okay,
over the growing season,
Right, right, got it.
if that makes it clear.
Yeah.
So you can take those kinds of methods. This is a paper by Wolfram Schlenker again and David Lavelle at Stanford. You can use it to estimate things like the impact of climate change in 2080 on African agriculture. Right? This is showing the distribution for African agriculture, bad outcome, mean outcome, good outcome under climate estimates for 2080. Right? You can see that on average, African agriculture is going to be harmed by climate change quite a bit. Right? Somewhere between, let's say, 10 and 20% lower yields. Right? A good outcome, it could be fine. And the particularly bad outcome, it's particularly bad. Right? This is for different crops. This is really pure science at this point. Well, it's interacting with human systems. Yes, sir.
But if you consider that maize, which is called corn, and is one of the biggest grains that's grown in the area, that's the one that looks, there's no good picture actually for that.
Yeah, there's no good picture for corn. So your corn is particularly sensitive to the high heats.
Yeah. And people depend a lot more on corn than say.
Right, and people eat a lot more corn, it's considered a lot more important. In Kenya, they say, if you haven't eaten corn, you haven't eaten, right? And we can think about things aside from just climate variability and things like soil, right? So this is a paper by Doug Allman at Columbia, Lena Edmund also at Columbia, and Edmund Ptolemy, right? This is showing the impact of extraordinarily small amounts of radioactive pollution. Fallout from Chernobyl. The identification they get here is basically using wind plumes and deposition rates of radioactive isotopes from Chernobyl fallout over parts of Sweden. They call their paper Chernobyl's Subclinical Legacy because basically the health impacts that they're able to tease out of this are subclinical. They wouldn't show up if you took a kid to the doctor. But demographically, they show up in lower test scores. Now, this is for just one specific district. Right? Basically, if you were in utero, if you were a baby in your mother's stomach, and you got exposed to fallout from Chernobyl, you're, like 10% lower on your standardized test. What was it? Yeah. In general, cognitive damage from amounts of radiation that we thought were tiny. Right? Think about it as environmental pollution, if you like. I'm going to zip through these a bit more. We don't need to go. This is showing that pollution influences people's marginal propensity to work. Right. This is particularly important for us in development. Right? So this is a pretty famous paper by Del Jones and Olkin, right, where they take sub-regional estimates of GDP in various countries, and they show that only for developing countries, higher temperatures substantially reduce economic growth. Right? They don't really tease out mechanisms too much in this paper. It's an empirical paper. Right? Reduces growth. In particular, they have some weak evidence that it might actually reduce growth rates, not just level in a given year. Yes?
I have a problem with this paper.
Yeah.
They don't find any effects of precipitation, and I think it has to do with how they measure the.
Yeah, I mean, I think precipitation is also complex. I think the point in this is that temperature influences a lot of things, and it's something that's teasing out in the empirical literature a lot these days. Things like labor productivity, for example. Precipitation has a lot of mechanisms that are very sort of case dependent. Right? And it's also precipitation variability versus levels, X, Y, and Z. But yeah, it's fair. I'll end with two last papers. One came out in Nature 2011. Saoxian and Kyle Meng, both from Columbia Sustainable Development. Mark King, who's at Columbia. Civil conflicts are associated with the global climate. What is this showing us? This is showing us that El Nino, which is, I realized actually a really nice way of thinking about what El Nino is the first primary way in which the climate varies over time is the seasons, right? Summer, winter, spring, fall. The second is El Nino, which is whether or not the Eastern Pacific is cold or hot. It's related to sort of a variety of physical processes, influences a lot of things, causes differences in temperature and rainfall around the world, which might potentially, or not might potentially, do affect things like agricultural outcomes. Right? So the takeaway result from this paper is that if you're in a La Nina, which is we can kind of stylize the cooler, wetter phase of the El Nino oscillation, your Mediterranean winter, if you will. and you jump to the El Nino phase, which is sort of the Mediterranean summer, hot and dry, if you are a country that's teleconnected, by which we mean your weather patterns are tied to El Nino's weather, to the El Nino circulation, then your risk of civil conflict doubles from about 3% a given year to about 6% a given year. If you're not in a teleconnected nation, absolutely nothing happens. Right? Global environment influences civil conflict outcomes. This is some work actually by Saul Shang again and Amir. Right? Causal impact of environmental catastrophe and macroeconomic growth. Don't take a picture of this and cite it because it's a submission. But basically what are we looking at here? We're looking at macroeconomic growth rates with a distributed lag model that goes out 20 years. We're looking at sort of the average treatment effect on your economy of a tropical cyclone. Right, so this is showing sort of the stylized baseline trend you would follow. You can think of this as 0. It's just we're putting it on an axis so you think about it as growth. Well, you have treatment at time 0, and then you have a very robust, slow decline in what your expected growth rate would have been. Right? This is coming out of the distributed lag model. 2 decades after you hit by a tropical cyclone, what's the average treatment effect that you guys like to call it? 5? 7? 7. 7. Right? GDP per capita is about 7% lower 2 decades after. And this is, I presume, this is 90th percentile tropical cyclone. So this is a 1 in 10 year event, if you will. Right?
Sorry. So this is for countries which have had tropical cyclones for a start, right?
Yes.
You have a subsample.
Yes.
And that's a particularly small group of countries. Or how large is that?
That's 101 countries out of the 190 or so in the sample. And it affects about, the population there is about 2.6 billion.
So I mean, one country that had significant tropical episodes,
Or
cyclone episodes.
have been exposed to tropical cyclones, yeah.
At all.
Right, and this, okay. And then you measure what's happened to the growth rate over the next 25 years, right?
So we measure the growth rate affected by tropical cyclones for the past 20 years, and then integrate that out to look at what the level effect was over after that period of time. So this is actually a changing storm. It's minus 7.5% in GDP levels compared to their counterfactual. So
Yeah,
it's like a within estimator. It's identifying off variation within each country.
Okay, so the counterfactual would be that
Counterfactual would be no storm.
no storm, what would have happened, and how do you estimate that?
So it's a panel distributed lag model. So it's a within estimation within each country.
Okay, sorry.
So this is a pretty exciting area of literature, I would say. This is sort of asking questions that are directly tied to things that we care about. I would argue this is directly relevant to things above and beyond development economics, or if you like, as I like to tell my students, that doesn't mean it only applies to the developing countries. If you look back not too long ago, the United States was a developing country too. Right? Look at photos from the 1930s if you forget about that, which again is in the blink of an eye as far as the world is concerned. So this is, I don't know, this is the stuff that I like to work on that, that I think it's, if you're interested in development, you do applied micro. Even if you don't do applied micro, do whatever you like. I think it's, go over and poke into the sciences literature and see what they have to say. I'm going to give you guys a quick tour of some of my own research in this area, and then we can chat. All right, so this was my job market paper last year. Again, joined with Saul Shang, who is a superhero in this field. Destruction, disinvestment, and death. Economic and human losses following environmental disaster. I feel like we should come up with a nickname for Saul that's like James Brown, hardest working man in show business. Something like that. So some very brief motivation, right? Environmental disasters produce major social costs. This paper came out or was done before the macro typhoon damages paper. But disasters cause damage, right? They kill people. They cause capital damages, right? We can estimate these immediately when the disaster hits, right? People get swept out to sea, or crushed by a building in an earthquake. Building get knocked down. They had a certain value. They got to be replaced. We can calculate the damages that way, right? can think about these damages as informing our approach to everything ranging from disaster mitigation to future expected costs of climate change, because climate change is expected to change things like the distribution and intensity of typhoons or tropical cyclones. Think about in terms of economic development, right, historical development, all the fact that we have all these geographical correlates with development today. Maybe there's something that's actually causal there, and not just a result of the fact that England was lucky in hitting on the Industrial Revolution when it did. Now, so what's concerning here is that we have a lot of evidence or a lot of estimates of sort of the immediate shock damages, but very little understanding in terms of what actually happens in terms of lag damages. And there's a lot of anecdotal evidence that suggests that we actually do a really good job, especially for disasters that can be sort of predicted or forewarned in harm's way. Right? But so, something happens, storm comes barreling along, get everyone out of the way. The storm still does a lot of damage, knocks down roads, knocks over buildings. It can be very disruptive. We look at things like, say, like USAID or Oxfam or all these agencies that will go in after disasters. They'll be like, a year later, they'll have a follow-up report and say like, oh, what was the big one? Cyclone Nargis in Burma. People were still incredibly poor and destitute a year or 2 years afterwards. But it's been very hard to sort of get traction on this. Right? So this paper we asked, do these disasters cause losses that only emerge after exposure to the event stops? Right? And if so, how large are they relative to these immediate ones? And can we say anything about how those losses occur? Can we tease out a mechanism? Right? Is Oxfam right that the worst part of the disaster, the damages that happen after, are the ones that are hard to observe but slow? So what we do is we take typhoons, actually the same typhoon data that's used for that paper that Amir and Saul did, and we run it over household surveys in the Philippines, economic and health data from the Philippines. Right? Again, our results may generalize to the roughly 2.3 billion people who get influenced by cyclones around the world. Give you sort of a quick preview of the results. And we find that post-disaster losses dramatically exceed measured immediate losses, both as reported in macro-level data and as estimated in our own data. Moreover, we find that the deaths that we estimate in our data are almost certainly caused by economic mechanisms. Right? In particular, what do we find? We find that the year after a typhoon, household incomes decline by a lot, average treatment effect of about 6.5% for a representative household in the Philippines. Expenditures go down, so we don't really see consumption smoothing. In particular, we see that purchase of sort of classic human capital investment goods, nutritious foods, medicine, education, are particularly elastic to typhoon incidents. Okay? So we go and we look at the health data. What do we specifically look at? We look at infant mortality. We find that infant mortality rises incredibly sharply. And in particular, we find that it's overwhelmingly female, in fact, not overwhelmingly strictly female, exhibits what we call an economic fingerprint. So we can't get perfect identification here in the sense that we can't tie individual infants to individual households. So what we do instead is we go and we cut the data every which way that we can in terms of where things happen, when they happen, what part of society you're in terms of socioeconomic status, timing, all these sorts of things, and basically show that exactly where the economic losses are occurring is where the deaths are occurring. Moreover, lending further credence to the hypothesis that this is basically the outcome of bad intra-household allocation of resources game subject to an income shock, we find that female infants, again, we say, well, in the Philippines we have mild sun bias, not as strong as in a lot of other countries, but it's documented there, right? So you'd expect female infants to be hit hard. to die for a given shock at all parts of the age distribution, in particular in utero. So it might just be there's a lack of available males, and that's why we're seeing absolutely nothing amongst the men, or amongst the boys. But the effect amongst girls is very, very strong. Looks exactly like the income and expenditure loss results in terms of time and in terms of intensity. Okay? So you say, okay, so we have the income losses, the expenditure losses, and the infant female deaths. They look very similar, at least with the one way of specifying things we already saw. Make some observations, think a little bit like scientists. We say, all right, well, these are all going down, right? Or infant mortality is rising, the other stuff is going down. Infant mortality is exclusively female, right? We've seen before that girls tend to suffer particularly hard for a given income shock or a given episode of hardness if you have any degree of sun bias, right? So maybe the hypothesis that can come together is, well, maybe these babies are dying because they're economic deaths. They're not trauma deaths, they're not exposure deaths. It's not that people are getting, they got sick because of the storm. This is because of adaptive human behavior. This is because of decisions that are being done ex post of the event. So this gives us some predictions, right? First of all, you should see basically the exact same households that lose income are the same households where babies are dying. Right? Moreover, you should expect that physical exposure shouldn't be the only thing, you shouldn't need
The time of death is not very clearly measured, so how can we